Hello. So now we will start with the implementation of linear regression, and I have prepared the data already in a new notebook. I have imported NumPy and scikit-learn. This is the Python built-in library for linear regression from sklearn.linear model in linear regression. But initially we will try to implement this the univariate formula. Okay, so let's see. First we convert this data, which is a list of tuples, into a matrix. Data mat to dot array and pass data, and I print data mat. Okay. So now x is data mat all rows in column 0. As I said earlier, you can also give a range like this, that is row 2 to 5 on column 0, but here we will just do all rows. There's some problem with this cell. Let's remove it, put it over here. Okay, next, and y is all rows in column 1. Okay, now what is m? Well, first we will do summation xy, that is, you know already, np dot sum x into y, not the dot product, it's the element wise product. Okay, minus n, that is the number of observations, and we can get it from the shape of this matrix, that is data underscore mat dot shape. So shape will give two values, one is 6 and one is 2. We will take 6, the first value, okay, into np dot mean of x into np dot mean of y. So put a bracket across it, then we will divide it by np dot sum of the square of all the x values. We need to do np dot square x minus, again we have to take the shape 0 into np dot mean x and square of that. This is a scalar, mean is a square scalar, so we get that as m. Not sure if I made the correct calculation. See if I can match up with my previous calculation, and c equal to np dot mean of y minus, okay, n into np dot mean of y, x. So here the two formulas have been written, and I made a small correction. There was a bracket missing over here, so I calculate m and c, and let's see the value of m and c. Okay, and suppose we wanted to predict for students who got 840, right? That was what we did in the slide. So how do we do that? We do predicted y equal to m into 840 plus c. Okay, and let's print predicted y. Okay, now let's use the library and see what happens. g equal to linear, we take a linear regression class, make an object out of it. If you are familiar with object-oriented programming, there's an operation called fit, fit, and we have to fit x and y here. We have to just reshape it a bit based on the shape it expects. It has to be, both has to be two-dimensional array. Y was one-dimensional, we are adding an extra dimension to it, so that just 1 cross, I mean 6 cross 1, it will have a shape like 6 cross 1, and we fit, and then we try to predict, and we want to predict 840. We create an numpy array with only one value, 840, and also reshape it because that's the way we have trained it, and we see, yeah, it's exactly same. I'm not sure what's the implementation of this linear regression, but however, it's a very simple few data, and we have almost got the same values. Okay, so next we will do multivariate regression, but we will do the gradient descent approach. Okay.